Assalamu alaikum wa rahmatullahi wa barakatuh. Our lesson today is about Pascal's principle, okay? At the first, this is glass container. It's filled with liquid, okay? And at the top is piston. Piston can move up and down, So, this piston and this glass container, we will deal with them as opened container, not closed container. Due to this piston can move up and down. If this piston can't move, we will deal with the container as closed, okay? What's meant by B1? B1, it is the pressure at point under the piston directly or at the top of surface of liquid. So this pressure will be the sum of pressure due to the weight of piston plus atmospheric pressure. So B1 equal pressure due to weight plus atmospheric pressure. When I want to calculate the pressure at A, it is a point inside the liquid. So it will be the sum of B1 plus rho GH, where rho GH, rho is the density of the liquid. Okay. If I load extra loads above piston, what will happen? I will increase pressure by delta B. So the total pressure will be P1 plus rho GH plus delta B. And then the piston doesn't move down. Why? The liquid is incompressible. And then if the pressure on the piston is increased to a certain limit, the glass container breaks down. So this means that the pressure acting on the piston is transferred to all parts of the liquid and to the walls of the container. So, what's meant by Pascal's principle? Pascal's principle, when pressure is applied on a liquid enclosed in a container, the pressure is transmitted in full to all parts of liquid as well as to walls container. Do you understand me? But please, we can't deal with gases. Why? Gases can be compressed due to the big intermolecular spaces between their molecules. So we can't apply Pascal's principle on gases, okay? What about the applications of Pascal's principle? Number 1, hydrochloric press. Number 2, hydrochloric brakes of the car. Number 3, hydrochloric lift. Number 4, chair of the dentist. We know that we can use a small force to raise or to lift a big load زي اللي بتشوفها في محطة البنزين. الworker make a small force and a big load will be raised up, okay? And الكوريك اللي بنرفع بيه العربية بنيجي نغير العجل, small force which leads to big force, okay? Now structure, 2 tubes, one of them is wide and the other is narrow, okay? And 2 pistons, okay? And please take care, wide everything with capital, F capital, A capital surface area, radius R capital, diameter D capital, okay? And narrow, all of them small, F small, surface area is small, radius are small, diameter D small. Do you understand? The space between them is filled with a liquid. We use it to lift high loads by small forces. Idea of work based on Pascal's principle, okay? Now, please, if I put here force, small force, what will happen? The pressure will transfer to all parts of liquid till reaches here. What will happen? The pressure will push up the car of the load. Again, force acting on surface area A. So the pressure is transferred to all parts of liquid till pressure pushes up the car. Do you understand me? And the big is big, but its movement is heavy. What's meant by this? in the wide tube, all of things is big. Force which is produced big. Surface area big. Radius big. Diameter big. But movement heavy. So if this in the narrow tube displacement y1 big, the displacement of wide tube will small because the movement heavy. If speed in the narrow big, the speed in the wide small, the movement is heavy. وانت بتعمل الكوريك بتعمل كذا ضغطة وبسرعة. العربية ما بتطلعش بسرعة، بتطلع بالراحة slow. and انت بتعمل كذا ضغطة، ايدك طالعة نازلة، بتعمل displacement كتير. الديسبليسمنت اللي بتطلعها حبة صغيرة. Do you understand me? Now when a force how it works we explained it. Pressure at small piston equal pressure on big piston when at a balance at horizontal level. B equal F small over A small. B equal F capital over A capital. So F capital over F small equal A capital over A small. Radius R square capital over R square small. D square capital over D square small. And what is mg? The force due to the load is weight. So we can replace force by mg. Please correct this. R square here, this square. Okay? All of them, big over small, big over small, big over small. For example, F capital over F small equal A capital over A small. If we replace F small by 10 Newton and A capital 1000 millimeter square and A small 10 millimeter square, we will get 1000 Newton. Do you imagine? You use 10 Newton to get 1000 Newton. Do you understand? Please correct this D small square. The big is big, but its movement is heavy. And the work done on the small piston equal work done on the big piston, applying the law of conservation of energy. So if y1, if small y1, the displacement in the small piston equal F capital y2. So F capital over F small equal y1 over y2. Only here small over big. So all the previous, big over small, F capital over F small, A capital over A small, only small over big, the displacement. Do you understand me? Now, the mechanical advantages of hydrochloric press. Its symbol is eta. It determined from the duration. Excellent. If capital F small, all big over all small, except displacement and velocity. Y1 small over Y2. V1 speed over narrow tube over speed over wide tube. Do you understand? And now the graph representation for relation between the two forces F capital and F small will be F capital over F small equal eta. Do you understand? The efficiency of the hydrochloric press doesn't reach 100% because the friction between the piston and the walls of the tube, so we will lose some of energy. Gas bubbles in the liquid, where some work is consumed in reducing the volume of bubbles. In liquid has gas bubbles, so we'll consume some work. Example number 1, page 96. Okay, I deal with it, but in different way. I deal with these rules. Okay, eta equal mg over f. Okay, so equal A over S small. I make my calculation equal 800 over 10, so M equal 800 kilogram. Do you understand? Deal with this rule. Write it at your book with highlighter. Do you understand me?